Good?
Yeah.
So somebody said, did we just dissolve? No, dissolving would be physical. We did not dissolve. We did this. How do we know? Well, because we saw 3 the chemical change. Now we'll do qualitative and quantitative. What'd you say? Tell me.
Color.
What kind of color? Be more specific.
Green.
What turned green?
Water.
So the liquid. So the liquid changed from, and it has to be a change. It's not just like it wasn't green to start with, right? Yellowish? I'm gonna be, this is where we can disagree here, because this is qualitative, right? You say green, I'm gonna say teal.
You spelled liquid.
I was looking at that, like, not quite catching it. Queed. Maybe queed.
Liquid.
I'm gonna say teal. You can say green if you want.
I'm gonna say teal as well.
That's qualitative because our opinions will vary. What else did we see?
Gas.
Yeah.
They started making like a red kind of like mist type of, I don't know.
Oh, we saw a gas.
Red gas.
And what's the vocabulary word? We saw effervescence of a gas, right?
Yes.
And what color?
Red.
Red, orange,
I'm
brown,
gonna say starting
whatever. Effervescence of orange, red, brown gas. Okay. That also is qualitative. We're not putting any numbers to it. Did we do anything quantitative?
No.
That is a clue. Temperature. We looked numerically at the temperature. Temperature changed from, do you remember what it was to start?
Like 21.
21.5.
Yeah, when we actually put it in there, I think it went down to 21.0. I did not record the maximum, but I know it got up to about 113. Did anybody notice a specific number? Let's just put about 113 degrees Celsius. So the temperature increased. Is that endo or exothermic?
It is endo.
Endothermic, because the surroundings warmed up big time. Wait. Did we just say the right thing?
Exo.
Exo, sorry.
Oh.
Exothermic! Yeah, exo, releasing of heat into the surroundings, outside, exoskeleton. This is weird to teachers, teachers. Oh, this is a generic fact. What makes Pyrex heat safe? This element right here. Silicate was on your vocab sheet, glass. Silicate is sand, silicon dioxide. Boron. What element number is it? What's its atomic number? You got it?
13 or something?
Is it 5? Let's confirm.
I guess.
It is really low.
5.5.
So boron is atomic number 5.
5.5.
Did you just say math?
Atomic number 5. That's kind of
5.5.
Oh, and a half. I said
Yeah.
just nice to know that boron, when you put boron into a glass, you make it very resistant to temperature change. Okay, we are going to write our very first chemical reaction. You wrote some of these in bio last year, right? No? Oh, okay. First, you start with words. All right, folks. What we start with?
Copper.
Pennies, which is copper, correct?
Nitric acid.
Was it pure nitric acid?
No.
So we can say it's a solution, right? Because we looked at it, it was only 70% nitric acid, the rest was water, okay? I highly doubt you have any idea what we made, although I did tell you they have a hazardous decomposition product. They both did, you wrote it down already. What's the name of the gas? Did you write down that product? Nitrogen oxide? And that was a gas, correct? We made something that turned the solution blue. Good. Do I have it on a previous? I was like, how did you know that? Okay. No, it's okay, just looking ahead. And we also made some additional water,
That's right there.
okay? Yeah, I have it there for you already. What do chemists like to do? Take these words and symbolize everything. What's the symbol for copper from the periodic table? And then you gotta tell me its state of matter. Nitric acid, the formula, HNO3, and that is an aqueous solution. It is floating around in water. That's how I tell you it's not pure. How do you read the arrow, by the way?
It's like equals.
Yields. This plus this yields, whatever, okay. Formula for nitrogen oxide. And what state of matter is it? Aerobic gas. We got copper nitrate, and we have some water. NO3 twice, right?
Yeah. And then
Yes.
it has low AQ.
AQ, that's right, and our H2O liquid.
It has like a
Cool. Let's look at nicer font. So you have this in your notes already? Oh, aren't you guys lucky? Okay, good. This handwriting's better. So something that's different is I added some numbers to make it balanced. We'll learn how to balance. Did you balance reactions before ever? We learned that later. Okay, definitions. Reactants are starting materials, products are ending materials. How do you tell them? Here's your dividing line. How many reactants do we have? Anything to the left is reactant. How many products did we make? 3. Do we have the same number of atoms on both sides of the equation? Without doing a detailed count, I will just tell you, yes, this reaction is written so that it obeys what law? That matter cannot be created or destroyed, only converted. We're watching a conversion process here. What law? Nope. What law states you cannot create or destroy matter, only convert it? Law of conservation of mass, and who said it? Antoine Lavoisier. I believe we're finished. Oh, we do need to do our EQ, sorry. But they're so easy, folks.
Of
They're
course,
so easy.
of course.
Who's that guy?
Just an FYI, when you do dangerous reactions, there's always the, how do I dispose of it question. Well, technically, I'm not supposed to pour it down the drain. I have to keep a special, and I will, I'll keep a, like a waste container. And then I call up somebody at the end of the year and I say, these are all the things in this container, you do something with it. And they do, it's great. They do more chemistry to make it. Okay. But how would I know how to dispose of it? I would go to the MSDS for the product that I made, which was copper nitrate. And that's where I would say, like, well, what do I do with this copper nitrate? And here it tells me you have to have a special disposal process determined by your institution. Well, yeah, there's usually certain criteria that of how you mix certain waste products. Yeah. All right, these are super easy. Let's have a volunteer to sail us home and finish. Who's going to read the questions and answers? Is that a hand? Is that a hand? Go.
Physical and chemical properties, how do we distinguish among them? And then ask, is there an interaction? And then yes, if it's chemical.
Next.
Physical and chemical changes. Ask, do I see a clue that bonds are breaking or forming? If it's chemical, then yes. And then properties, or how to distinguish among properties and changes. Ask, am I focused on the interaction or bonds? And then there's an interaction, there's properties, and if there's changes, there's bonds.
Or if there's bonds, then it's a change.
Yeah, there's a change, sorry.
That's it, folks. chemical and physical properties and changes. You got nice beautiful demo in your head. We did all our safety information. Life is amazing. Would you like to ask any questions? All right, the remainder of the time is for you to, work on that awesome worksheet and or watch the next Crash Course video. When do we get out of here? How much time do we have? 20 minutes?
I don't know.
Or more? I'll let you know. All right, thanks. Woo! Hey.